At this point, you should know what a RAG system is. So RAG stands for Retrieval Augmented Generation. So the idea is that large language models are trained on a certain knowledge base. But the main goal of using large language models is that we want to inject, in some ways, our own data so we can converse with our own data. So let's say you have documents in your organization and you want to chat with your documents, so ask questions about your documents. That's when RAG systems come into place. But now, to make your RAG systems even better, which again, you have your RAG system, these are the ones that are dealing with large language models, and also that is what's driving your AI applications. And so to make your RAG systems, your AI applications even better, which means you have to make your RAG systems even better, more optimized, we need to implement certain techniques to make that happen, to supercharge your RAG systems. And so that's what we're going to be using or learning in this mini course, this technique with KG or knowledge graphs to supercharge your AI-based applications. Okay, so without any further ado, let's go ahead and get started. All right, so I hope you are ready and excited to get started. So we are going to get started with the knowledge graphics deep dive. So what we'll do is we are going to learn what they are. What are these things called knowledge graphs, the motivation behind, and I'm going to look at the advantages, key concepts, and structure, components, some use cases, and lots of hands-on, and not just only advantages, but also challenges of using knowledge graphs. Right? So let's go ahead and get started. So of course, we always have to define the thing that we're trying to learn. Knowledge graphs or knowledge graph. What is it? Well, usually you will see me writing or saying KG for short, or you will see it written like that, KG for short. That stands for knowledge graph. So what is it? Well, a knowledge graph essentially is a structured representation of facts and also relationships within a specific domain. So this actually enables machines to understand and reason about the world in a way similar to us humans do. They are used in many different industries and also many different applications that you might have heard of, such as search engines, recommendation systems, and artificial intelligence, AI. So these are used for enhanced data integration, management, and retrieval. If you look at this diagram here, imagine that we have at the center of everything Sir Albert Einstein. And we know that Albert Einstein was a physicist, okay, which means he studied physics. But we also know that Mr. Einstein played the violin. We also know that Mr. Einstein also was interested in math, where at the center of everything we have Mr. Einstein. And then we have these arrows that represent some sort of a relationships. That's why we have the structured representation of facts. What are the facts? The facts is that Mr. Albert Einstein is interested in math, studied physics, and played violin. So these are the relationships of Mr. Einstein as it pertains to the violin, physics, and math. So that is the very basic representation of a knowledge graph. Let's go ahead and look at some of the key concepts when it comes to a knowledge graph. So we said that you see here we have Albert Einstein, and we know that Albert Einstein studied physics. The key concepts here, the key components I would say, we have Albert Einstein. This first point, the starting point, is what we call an entity. Now, different domains, they may have different names, nodes, and so forth, but it is indeed an entity. So entities or entity are the primary nodes or vertices in a knowledge graph because it represents objects or concepts. This object here is Mr. Albert Einstein. And that could include a lot of things. It could include people, places, organizations, and events. But then, at the other end, we also have another entity. In this case, it's physics. It's a domain of some sort. Okay? But then we have in the middle here this arrow that tells us what is the relationship that exists between Mr. Einstein to physics. Well, this is what we call an edge. That's the relationship. So essentially, the key concepts that we have here is entities. These are the objects, the nodes, the vertices. They represent objects or concepts. And then we have this relationship. So we are relating what's on the left to something else on the right. And these are called edges. So they're connecting. They're presenting how entities are related to each other. But also, with our entities, we could have what we call attributes. So these are properties or characteristics of those entities. For example, the entity Albert Einstein might have attributes like birth date, nationality, and professional. It's something that I didn't show here, but that is something that we could have, and I'll show you in a second here. So this is what we call triples. So triples is the basic building block of knowledge graphs because it consists of a subject, Mr. Einstein. We have what we call the predicate, studied, and then we have another object. For instance, in this case, Albert Einstein studied physics. That is indeed what we call a triple. Okay, so let's continue here. We know that we have these entities, edge and relationship, and another entity. So entity, we have the edge, and then we have another entity. And so we also have, like I said earlier, attributes. So these nodes, these entities, could have attributes. So essentially properties that identify that are part of the node or the entity. So Einstein has birth date, nationality, and a profession. We say that subject is going to be Albert, predicate is going to be studied, and the object is going to be physics. Now we have the definition of what a graph knowledge is and the main building blocks, the key concepts. So as we know, a knowledge graph has what we call a graph-based structure. What that means is that we have nodes, edges, that allows us to model the real world knowledge. And that is the beauty of knowledge graphs, and that's the reason why they're called knowledge graphs. But also they have ontology. So what is this ontology? Ontology is the schema, so essentially is the map or the mapping that defines the types of entities, relationships, and attributes of our knowledge graph. And also we have what we call taxonomy. Taxonomy is the hierarchical classification of those entities that we have. So all those nodes and relationships and everything. So looking at this structure here, let's look at nodes. So naming is very important, of course, but most of these namings, most of these terminologies are actually the same. It's just that sometimes they may have different names. Okay, so we talked about nodes, same thing as an entity, an object, right, in this case. So a node or nodes, they do represent entities or instances. And then we have edges. These, as you know, are relationships between those entities. And also we have what we call labels. So labels, these are little tags that can be, I should say, assigned to each one of those nodes, as well as the edges to define their own types. Okay. And so we also have properties. So these are just other metadata, right? Pieces of information or attribute about nodes and edges. So this is just a general structure of a graph, mathematically speaking, but also when we talk about machine learning, talking about AI, and large language models and so forth. Okay, so of course, once we understand the structure, we understand what nodes are, the key concepts and everything, the next question is, okay, what is the construction process for knowledge graphs? How do you build them? Well, there are different ways to construct or build KGs or knowledge graphs. First way is manual, right? You can actually, there are software out there where you can manually create inputs of data into a graph. You can also create some sort of automation, right, to extract data using different algorithms and natural language processing to extract information from unstructured data sources like text, documents, databases, and so forth, and aggregate all of that to put into, of course, a knowledge graph format. And that is the point that we're going to be using in this course. And also we can go ahead and do some crowdsourcing. So essentially getting information, getting input, getting data from a large number of various resources or various sources all over the place to populate and refine the graph. Now let's talk about the applicability or the application. So where are KGs or knowledge graphs used, or where can they be used? So knowledge graphs have been around for a very long time. In fact, all of that comes actually from mathematical graphs, the concept really. And so there are a lot of applicability when it comes to knowledge graphs. So you can use knowledge graphs in search engines. When we use knowledge graph, they enhance search capabilities by understanding the context and the relationship that exists between the search terms. In fact, Google's knowledge graph, there's a thing, it is a knowledge graph. So the representation of data behind the scene is like a graph, as you see there, with nodes, relationships, attributes, and all of that. Also used in recommendation systems because it provides a more personalized recommendation by understanding user preferences and also, again, very importantly, the relationships between products or services. For instance, Joe tends to like classic movies and so forth. So the recommendation system would map all of Joe's interests and likes and dislikes to create a graph, a knowledge graph, so that it's easier to traverse through to find what Joe might want to watch next. As an example, data integration, because here we can combine data from different sources into a one unified framework, which enables more effective analysis and also decision making. And as you know, in AI and machine learning, because enhanced machine understanding and also reasoning by providing structured knowledge. So it's all about structured knowledge. It's all about traversing quickly to find meaningful relationship between those nodes, which incidentally represent information. Knowledge graphs, of course, they have a lot of advantages. Let's look at some of them. Well, number one is that they enable integration of different types of data, so in this case heterogeneous data sources, into one unique unified framework, and also ensures accuracy through well-defined ontologies and taxonomies. Because if you look at a graph, as you see, we have nodes, we have relationships, and these relationships are directly connected with those nodes, which creates this very tight, well-defined structure and ontology for our data. It also allows complex queries about the relationships between those entities, which is a bit harder or complex to do when we are querying data that is saved in a SQL database, for instance. And the other advantage to using knowledge graphs is that they allow machines to probe in and infer new knowledge from existing data. Again, because all the knowledge is in form of a graph. So there are relationships between the entities and the nodes that are easy to traverse through to get to where we need to get and extract the results or the information that is needed. But of course, we need to be aware that there are some challenges to using knowledge graphs. Number one, data quality, which means that it can be a little bit difficult and complex to make sure that the data itself is accurate and is reliable. And also when it comes to scalability, trying to manage and process extremely large scale knowledge base or knowledge graphs can be very difficult to do that efficiently. So as we have more data, meaning as we need to process large scale knowledge graphs, it gets a little bit more complicated. Of course, there is complexity added to that because when we try to develop and maintain comprehensive ontologies and taxonomies, these structures, these large structures, that can also add more complexity, which is part of the challenge when it comes to knowledge graphs. And data privacy, this is a huge one. It can be a little bit difficult. There are things in place, of course, to mediate that, but protecting sensitive information when we are using those knowledge graphs can be a bit challenging. Right, so in summary, knowledge graphs are a powerful tool for structuring and reasoning about complex data. As you can see, it's graphs. The great thing about KGs is that they enhance the capabilities of AI systems, which means they improve search and recommendation engines, and they do facilitate data integration and analysis across various domains, which we'll see as we go through this course. So obviously, by understanding the fundamentals of knowledge graphs, one can leverage their potential to create smarter, more intuitive systems, specifically related to RAG systems. All right, I'll see you next. All right, now we're going to continue with knowledge graphs, of course, and doing a deep dive, but now we're going to start doing more of hands-on. So we're going to look into building a knowledge graph. So as we do that, we'll introduce a few tools, namely the Neo4J. We're going to look at relationships, entities, and of course, all of that through hands-on. So building a knowledge graph. So what we'll be doing is we're going to take this structure here we've seen before, maybe a little bit enhanced, and put that into an actual knowledge graph. So you see here, Albert, again, as the focus, as the subject here, the main node. You can see that he is related to physics because he studied physics. Albert also won Nobel Prize in physics, and he was born in Germany and also died in the USA. All right, so this is just a very simple knowledge graph that we are going to try and put together in code so you can see how that is done. But before we move forward here, we need to look at different technologies and languages that allow us to actually do that. We have different technologies and languages to represent KGs in code. So the first one here is the RDF, Resource Description Framework. We have the Sparkle, I think Sparkle, which is Sparkle Protocol and RDF Query Language. We have OWL, this is a Web Ontology Language, and we have Neo4J. Now, there are many others out there that I'm not going to take the time to tell you all of them. You can do some research, but these are some of the basics, some of the most popular ones. And in this course, we're going to be using Neo4J because it's just easier to work with. So going back to the example, this knowledge graph here, just to make sure that we define everything because we're still in the beginning here. Remember, again, we're defining the entities and the relationships. That is the basic idea when it comes to knowledge graph. So what would be the entities here? Well, the entities would be Albert Einstein. We have physics, Nobel Prize, physics, right? Germany and USA. So these are what we call entities. And the relationships in this case would be Albert Einstein studied physics, as we've discussed. Albert Einstein won Nobel Prize in physics. Albert Einstein was born in Germany. Albert Einstein died in the USA. So these are the relationships that govern the entities. Okay, so that's something to always keep in mind. It doesn't matter how large, how complex our knowledge graph get, they always follow this structure. We have entities and relationships. Of course, within entities, we saw we have other metadata, attributes, and so forth that we can pass along. But in essence, that is the fundamental, the foundation of building a knowledge graph. Now, when it comes to representing this structure in code, or in this case in Cypher, which is the query language used with Neo4j, it's very simple because to represent, for instance, the relationship between Albert Einstein and Nobel Prize physics, we would create something like this. So what we're doing here, you can see that we're saying creating a variable a, and the type is a person, and we're saying we have this arrow that's kind of hard to see, but it's an arrow with square brackets, and we have studied. So studied is indeed this here. That is the relationship, that is the edge. So we're saying here the person a and the variable a studied p, variable p, which represents physics. So person a in this case is going to be Albert. We're saying the relationship between Albert and physics is that studied. So, okay, the same thing would do for person one, Nobel Prize. So we're saying Albert is the person one, that's a relationship, Nobel Prize. And person died in USA. So you can see that the actual relationship, that's also added inside of the graph. And that is the beauty of, you will see later, of having KGs, of building knowledge graph, is because all these pieces that are important are attached as data types. So we talked about that we're going to be using a tool called Neo4J. What is that? Well, Neo4J is a graph database. So it's more than just a graph database. It is a graph database management system that has all the things set up for us to start doing very complex transaction on our data. Okay, so it has a lot of things because it follows the ACID compliant transactional. So which that means is that it is very secure. It follows all the protocols and everything that most databases, systems, management systems need to follow in order for them to be scalable, reliable, and so forth. This course is not about Neo4J, but I just want to introduce to you so that you know the basics, because that's what we're going to be using. Now, here are some key concepts. Well, of course, there is nodes, relationships, of course, properties, labels, and most importantly, we have Cypher, which is the query language used to interact with the graph data. And we'll see all of that. So what we'll do next is we are going to set up Neo4J so that we can start interacting with it. Hopefully start seeing some amazing things happen with our data. So before we move forward and I show you how to set everything up for Neo4J, so we can go through all of that, I just want to give you a quick overview of what is possible. So this is my Neo4J dashboard here. So there's a lot of things, no worries, this may not make a lot of sense, but these are nodes that I've created prior to recording this course in my preparation. There's a lot of things here. So all of these will make sense once we get there. So the idea here is that we have these nodes, have over 366 nodes. And remember, nodes, it's just that central vertex, the object, subject, right? All of those entities, I should say. And these are the entities of some data that I put together, all right? And if I click here for this one here, you can see we have this very nice user interface. It's hard to see because everything is kind of small so that you can see everything. But this is part of the query language that is being passed to get this result. So as I click on each one of this, there are, you can see, I'm going to move this perhaps a little bit. So you can see I have these nodes. These are all entities that I can click and they give me some information. Again, don't worry, we're going to go through all of this. Just want to show you. But most importantly, I'm going to run a command here. This is going to go ahead and return all the paths, the whole graphs for all the data that I have. And you can see at the bottom also I have these relationships. Relationships again are all those arrows, right, that relate those nodes or entities. And so I have over 895 entities or relationships, I should say, right? So many of them. And so I'm going to run this real quick here so you can see what would happen. Let me just, I think I made a mistake. Let's start again. And let's remove the pounds. Okay, let's go ahead and run. We should see this very nice graph that should be shown here. Look at that. So this is the graph that represents the entire nodes as well as the relationships of everything. And all of them are in different clusters. So if I zoom in, let me zoom in into at least one of this. And if I click, you can see Aurelian. Okay, so this is Roman Empire. And I can continue zooming in and you can see all of these arrows. This is what we're talking about. So we have all of this information now that is easy to manage, because you can visually see the mentions as the arrows. These are the relationship, and we have all these different nodes, and I can zoom out and you can see the whole thing. Okay, and as I click, I can move them around. You can see that the graph is actually moving around to show me the fluidity of it all. All right. Very good. So if I continue to zoom in, you can see as an example here, it says fall of the, if I click, there's a lot of information about what I'm clicking. So the summary and everything. Now, no worries, we're going to get to that and you will see exactly how to put all of this together by the end of this course. So that is what I want to show you what you're going to be able to do in a little bit here. So at the end of this course, you're going to be able to take data, unstructured data, text from somewhere, and parse it all throughout and then put everything into this Neo4j database, really, that will allow us to create embeddings, create all these different things so that we are able to finally create a KG, a knowledge graph, as you see here. And then we can run certain queries to get the actual data. Okay, so that's what I want to show you. And next video, I'm going to go and show you how to create an account and go from there. Okay, let's go ahead and set up Neo4j. And first thing you need to do, go to Google and say Neo4j, graph database, powerful native graph storage, data science, and blah, blah, blah. Wonderful. And let's go to the second one. So let's go to this one here. Now, there's two options. You can download Neo4j Desktop so that you can run it locally, or you can use the web version, which is the one that we're going to be doing. Okay, so I'm going to just go to NeoGraph like that. Now, the thing about NeoGraph is that you will have to create an account. It's very simple. Go ahead and say get started, and it's going to tell you to start free. So start free. Okay, so what it will do is you're going to add your email to start the process of creating an account. Now, or you can just say continue with Google or continue with your organization and so forth. Okay, now it's going to go through a process and will ask you to add a phone number and things like that. This is a very reputable company, so just follow all the things that they're telling you to do. Okay, so once you have everything set up, you have an account and everything, you're going to be able to create instances. So this is going to be cloud-based database. So what you do is just click create instance. No worries, it says professional and you have to pay and everything, but you are allowed to have one free instance here. No credit card required. You can access to all great graph tools and everything. So go ahead and say try for free. So once you do that, this is very important. You can see that we have this password and everything. And what you want to do is actually want to download this information because you're going to need this to connect programmatically. So make sure you say download. It's going to be downloaded. And once you do that, it's going to create that instance. It may take a few minutes, so just wait for a bit. Now, one thing you'll notice here is that we have this information here, Neo4j, and then this is the link that you need. Okay, URL, and then we have the username. This is all given, okay, and instance ID, instance name, and all of that. So what we're going to be doing is we're going to take this and add into our environment variable. By the way, don't share this with anybody because they'll be able to start using your cloud instance, okay, of NeoGraph, of GraphQL, of knowledge graph. They're going to be using your instance. So just save that, and once I'm done, I'm going to delete everything anyway. Okay, so what it will do really is you're going to take all this information. So I'm going to start by taking this URI, go to environment variables, and I'm going to paste it all in here. But one thing you also noticed, I'm going to just paste at the bottom here. You will notice that this one that I added here, I added Neo4j plus SSC. The reason why is because when I tried this way, it was giving me connection error. So if you have issues connecting with this format here, then make sure you add this. So I'm just going to go ahead and add this right away so that I don't have issues. But you should try before without adding these two the SSC like that. Okay. So there we go. That is the first thing. And then the username is going to be the same. So make sure that you get the exact username that you have here. It should be like that. And of course, the password, I'm going to just copy the whole thing for the password. Okay. And I'm going to put all of the other ones too. And at this point, you should have the OpenAPI key added there. And later, we're going to see that we need this open endpoint. Okay. So we should have all of this information now. Again, make sure that you add plus SSC as opposed to what they give you, which is just plus S, if you're having issues later connecting to the database. So let's go back here. You can see that after a few moments, we should have indeed the instance is running. So uses Google Cloud to run your instance. And if you click here, this is going to give you indeed the whole thing for you to go ahead and get in. Okay, so now if click, you're going to say you need to connect to a database. So it gives you the information. And add the database, Neo that, and the password, make sure you go back and get this password that was generated. So it has to be exactly that one. That's why we had to save it. I'm going to save that and say connect. All right, so after a few moments, you can see that you should be in that we have indeed our database information, and there's nothing, there's no nodes, no relationship, nothing. All right, very good. So this is really good. Make sure you get to this point and you should be in. All right, so once we have everything set up, let's go ahead and see how we can set up our development environment so we can connect to our Neo4J programmatically. So we should have our instance still running, which is really good. That's why it's green. And that's good. Okay, let's go ahead and do that. So we have our environment variables, everything set up. The first thing we need to do is, of course, install the dependency. Now make sure, of course, you have the virtual environment set up and it's running. So I'm going to say Python, or pip install, I should say, Neo4J like this, and should get the dependency that we need. And the next thing we're going to do is let's go ahead and get the .env. So pip install, we should have that already, say python .env. So what this will do, right, it's already installed. I think it comes already with it. It will allow us to get environment variables into our code. So that's very, very handy. Okay, so I have this file called simple_kj, and I'm going to, actually it's a folder. Let's go ahead and create a file here. So it's a kg simple.py as such. And so what we'll do here is we're going to set up so that we're able to connect to our remote database. So let's go ahead and import a few things that we already have here real quick. So .env, os, and let's go ahead and import the Neo4J and get the graph database, because that is the instance that we need. And as always, let's go ahead and get the load.env so we are able to load all of the environment variables from the file. Okay, so what we're going to do next is let's go ahead and set up everything that we need to set up. So I have everything set up, so I'm going to just go get it and put it here. So what's happening here is that we are getting all of the credentials that we need for our database to connect to them. So in this case, I'm actually getting this Aura instance name from our environment variable, and for that, so this auth here, I created this structure so that we have both the username and the password. Okay. Now, of course, make sure that all these names that we have here are exactly the same as we put in our .env file. Okay, so the next thing is we need to get a driver. So we need to pull in a driver for our graph database. So I'm going to put that in a variable, and it's going to be graph database driver, and we pass the Neo4J URI. That's very important, and the auth as well, which includes both username and the password. Okay, and database also pass the database name, which is going to be under Neo4J database. Okay, so we're good. Let's go ahead and test it out to see if this works. So I'm going to create a function here. We'll have a function that will use the driver and connect to the database. Okay, so I'm going to just leave that as that, since we instantiated at the top. So what we're doing is just we're going through the driver and create a session, which then we pass the database name again. And we're just running that session and pass in, this is indeed the query language Cypher, to say, go ahead and find anything that you can find and return the count of whatever you may find in our database, which in this case, you can see it's literally empty. It doesn't have anything. In this case, if we find something, just get us the count of the items that we have. In the other case, give us the error. And finally, we need to go ahead and always close this connection. That's very important. Okay, let's go ahead and call this function here real quick to see what will happen. Let's go ahead and run. It says number of nodes 0. So no errors happen. That's good. That means we are connected to our database here. If we had anything at all, it would give us the number of nodes. So this is good. Make sure, again, if you're having errors, number one, like I said earlier, make sure that you are indeed changing this Neo4J plus SS at that SS as I've shown you earlier. So you can see, change that to plus SSC, and the rest is the same to make sure that it works, especially if you're on Mac. If you are on Windows or Linux, I think you should be fine. If that works for you, that's okay. You don't have to change anything. But if you get that error, make sure, first of all, you change this to plus SCC on Mac specifically, and then make sure all of the other credentials are set correctly. Okay, so now that we know we're connected, let's go ahead and create an entity. So I'm going to put that inside of a function. That way it's way simpler. And so we have this function here called create entities. And so what we'll do here, we're going to create an Einstein node on entity. So see what's inside here. What's importantly to note is that this is what we call the Cypher query language. So we say merge, so essentially say go ahead and merge together. So create something, and we pass this syntax here with a, that's just the variable name, and then person will be the type, for instance. And we say we want to create a node, an entity named Albert Einstein of type person, which is going to be held in a as the variable. Okay, and that's what we do, and we'll see that later. We're going to be able to run this. I'm going to put this way, that way we're able to see in our backend here the whole structure. So we're going to put together the structure that we saw before, the KG, the knowledge graph of Einstein. And we create the first node, and then here we also create the other nodes, I should say, the subject now. So the subject is going to be physics, and then we have Nobel Prize, give it the actual name, which is going to be Nobel Prize in Physics, right? And then we have the country, which is going to be Germany, and the other country as a node is going to be USA. So we're creating all of those nodes that you saw previously. And so once we create the entities, now we need to create the relationships. How do we create that? Oh, well, it's very simple. So I'll put that in a function again. So we have a few relationships. So we are passing here, say match, and we pass the Albert Einstein, and the subject is physics. So, and then we say merge the A, which is Albert Einstein, the person that we have here, and we have that syntax that I showed you earlier, right? This arrow, and then we have this studied like that to P. So that means we're relating A, person, which is Albert Einstein, to physics. So there is that relationship. So now we're creating that edge, that relationship, studied relationship, and we're going to create the one relationship. So the same thing, the syntax is the same, right? A is person, Albert Einstein, and what did they win? They won a Nobel Prize, okay, which is the actual value is this, what do you see? The text, right? And the same thing for born in relationship. So in this case, he was born in G, Albert Einstein, person was born in Germany. So the syntax is can be a little bit daunting in the beginning, but that is what's happening here. And the died in a relationship, the same thing. Einstein, person, died in U, in this case, USA. Very good. So next, a function that allows us to connect and run a very simple Cypher query so that we can put stuff into the actual database. So here, I'm actually instantiating a new graph database driver here inside. You can do that as well. And I'm doing the same thing we did before to see what's inside. So now I'm saying Cypher is going to be whatever we pass in here, the query we pass. We're going to go ahead and create a new session and run that session. And then, of course, for each result that we get the name for each one of the items or entities that we're getting. Okay, finally close. And I'm going to create another one here, which is going to be function to connect and run a Cypher query. Do the same thing. So you can see we do the same thing here, but now we're going to be getting the actual path. Okay, we'll see the differences, but everything is the same, but we are printing the path, which is going to be, in this case, the relationship, right? The arrows. All right, so let's go ahead and see how this would work. First of all, let me go ahead and get the function to go ahead and build our knowledge graph so we see something hopefully in the back end. So we're going to go ahead and open a session, again, a driver, and then we pass the same thing, the database, create that session, and then we call the entities. So we say session, execute, write, and create entities. Create entities, remember, is what we have here. So we're going to pass this object to say run, that is the session, and it's going to run this, all of this, create all of the nodes. Very good. And then of course we create entities, we are going to create the relationships. Session, execute, write, and pass in the relationship function. Create all of the relationships: study, won, born, and died in. All right, so what we'll do next is I'm going to go ahead, build knowledge graph real quick and see what we'll see. So if all goes well, we should be able to see a knowledge graph. So Python. So if you go here, I'm going to refresh a few times. You can see it's loading. This should, voila, and it was really fast. And all of a sudden we have those 2 nodes, or I should say 5 nodes. We have the country, Nobel Prize, person, and the subject. And then we have the relationship, which should be 4. All right. So if I click on this, you can see right away, voila, you can see that once you click, you see that was physics that was clicked. And if I go back here, Nobel Prize, that's the entity. And as you click on them, you can see that there is indeed what is being, this is what was called to return all of them. So now, if I go to relationship born, you can see that it shows indeed this, right? So Einstein, born in Germany. Very good. And if I say died, you can see that it's going to show that indeed Einstein died in, there's a relationship, there's 2 entities, nodes, and the relationship is died in USA. If I click each one of these, it gives us the name, it's Einstein, and this is the value that was added. So each one of these arrows on this relationship, it has its own value or ID that is created. And of course, we have the ID 4, and the name is USA. Okay, each one of these items has its own internal ID that is created. The same thing with 1 and so forth. All right, so we were able to run to build our knowledge graph, and you can see the actual full structure. And one thing you can do is to see the entire graph, we can run this query. So essentially we're saying just get everything and return everything. In this case, if you run this, and what you see, we now have results overview. We have all the nodes, 1, 2, 3, 4, 5. They're showing everything. And this is the actual graph. Right? This is the representation of our data in a knowledge graph format. Very good. So at the center, we have Albert Einstein. And then we have that he won a Nobel Prize, right? And the relationship is born in Germany and died in the USA, and so forth. All right, congratulations. Okay, let's run this query graph simple, which requires us to pass the Cypher query. So it's a simple query, just to return some names that we get from each one of our entities or nodes. So as always, well, first we need to create that query. So we have the simple query that just runs through, and we say return n, the variable, right, which will have the object, in this case, the nodes, and we're going to go and get the name, and we're going to put all of that as name, just a holder variable. Okay, so now I'm just going to go ahead and instead of creating yet another graph, let's go ahead and comment that out. And so now let's go ahead and run a simple query. Well, to do so, we're just going to go ahead and paste this one here. So now we're saying query graph simple and pass the actual query, which is this one here. So this is the Cypher query to find all node names. Let's go ahead and run this real quick and see. And okay, that's good. So you can see that it got Albert Einstein, physics, Nobel Prize in physics, Germany, and USA. So it got all of the nodes, which is what we have here. So we have all of these nodes here. So we have Albert Einstein, USA, Germany, Nobel Prize, and physics. All right, very simply, we are able to query using Cypher language, as you see here, query language. All right, so in this section, we did a few things. We introduced Neo4J, did setup, we introduced what it is and how it works. We created an account, create a graph database as well, and we looked into the Neo4J browser and see the whole console, how things are laid out and all of that. Of course, we were able to visually see all of the knowledge graphs that were created in the back end, and we also were able to create a knowledge graph programmatically, connect from our code to the back end, and able also to query the knowledge graph thoroughly. Okay, so at this point, you should have the basics, the fundamentals on how to use Neo4j to set up things in the back end and see visually the graphs, the entities, the relationships, and so forth all together. Okay, this is just the beginning, but you should have a very solid foundation at this point. So next, we're going to continue in our journey learning about knowledge graphs for RAG. Okay, so I hope you enjoyed this mini course where you should have the tools that you need to supercharge your AI-based applications that are dealing with large language models. And of course, you have RAG systems. And so that was the whole deal about this mini course. I wanted to show you how to use this technique based on knowledge graphs to enhance your RAG systems, which actually also enhances your AI-based applications. So that's it for me. If you are new to this channel, please subscribe, because there's a lot of content here. And also, if you're interested in the full course where I go deeper into this subject, check out the links in the description. That would help me, will help the channel, and support this channel. So that would be awesome. Okay, so thank you so much for your time. And if you made it to this point, the end of this course, that means you are a champion, because most people don't even get to 10 minutes of anything. So you made it here. Thank you so much. And to let me know that you made it to this point, I would love to see you leave a comment in the description below. Just leave a comment to say what you thought of this course and what other things you would like to see me cover in the next videos or lectures or courses. Thank you so much for your time, and till next time, be well. Okay, bye for now.